Something unusual is happening in the modern car world, and it is not just about speed, design, or who builds the fastest machines anymore. It is about control, ownership, and a hidden battle between people who buy cars and the companies that build them. In the middle of this situation, a story has taken attention from millions of viewers online. It involves a well-known car builder and YouTuber, Mat Armstrong, a powerful automotive giant like Ferrari, and even global figures like Elon Musk. At the center of everything is a simple but powerful question. When you buy a car, do you truly own it, or are you only renting it from the company in a hidden way? This story starts with a wrecked supercar that most people would call completely finished. It is not just damaged, it is deeply broken both mechanically and electronically. Normally, such a car would be written off and sent to scrap or auction for parts. But in this case, someone decided to rebuild it from the ground up. That decision turned a simple repair project into something much bigger, something that slowly grew into a global debate about technology, software locks, and the rights of car owners. The situation becomes even more intense when we add modern car systems into the picture. Today's supercars are no longer just mechanical machines. They are also computers on wheels, controlled by complex software systems that decide whether the car can even start or move as the rebuild progresses. The car is physically restored step by step. Parts are replaced, carbon fiber panels are repaired, wiring systems are rebuilt, and the engine is brought back to life mechanically. On the outside, everything starts to look complete again. But inside the system, something is still missing. The software refuses to cooperate. A hidden digital lock prevents the engine from fully activating. No matter how perfect the mechanical work is, the car refuses to start. This is where the problem shifts from being a mechanical challenge to a digital one. And this is where the story begins to feel less like a normal car rebuild and more like a battle between human skill and corporate control. At the same time, public attention grows rapidly. Online communities start discussing whether modern cars are becoming lock systems controlled by manufacturers. Some people argue that companies like Ferrari are protecting safety and quality. Others believe that once a car is sold, the manufacturer should no longer have the power to disable or restrict it. The debate spreads beyond car enthusiasts and reaches legal experts, engineers, and even political discussions about digital ownership. Suddenly, a single rebuild project turns into a symbol of a much larger issue affecting the entire automotive industry. To understand how the situation became so big, it is important to look at the person at the center of it. Mat Armstrong is not a traditional mechanic working in a factory or dealership. He is a content creator who built his reputation by taking damaged, often nearly destroyed cars and rebuilding them in his own garage. His approach is simple but powerful. Buy broken performance cars, document every step of repair, and show the full reality of what it takes to bring them back to life. Unlike many automotive channels that only show finished results, he shows everything: the mistakes, the failures, the delays, and the technical challenges that come with rebuilding high-performance machines. This style of content created a strong connection with viewers because it feels real and unfiltered. Instead of polished showroom presentations, audiences see real hands-on work. Over time, his projects grew bigger and more complex. He moved from basic cars to high-end performance machines, including brands like BMW, Lamborghini, and eventually even more advanced supercars. Each project brought new technical challenges, but also more attention from viewers who enjoyed watching difficult builds being solved step by step. His workshop became a kind of experimental space where damaged engineering is brought back to life through patience, skill, and problem-solving. However, as the level of cars increased, so did the complexity of modern automotive systems. Older cars were mostly mechanical, meaning that if you fix the engine, transmission, and wiring, the car would run again. But modern supercars from companies like Ferrari are different. They depend heavily on electronic control units, encrypted software systems, and digital authentication processes. These systems are designed not only for performance, but also for control. They can decide whether a car is allowed to operate based on internal checks that are not always visible to the owner or mechanic. This is where the rebuild project starts to change direction. What begins as a physical restoration slowly turns into a software problem. Even after replacing damaged parts and restoring the structure of the vehicle, the car refuses to fully function. The system behaves as if something is still wrong, even when everything appears correct. Error messages appear and the car remains inactive. This creates confusion because the mechanical side of the project is complete, but the digital side remains locked at this stage. The situation is no longer just about one car. It becomes part of a larger discussion about modern technology and ownership. Many people begin to ask whether manufacturers should have the right to restrict a product after it has been sold. Others defend the companies, arguing that advanced systems require strict control to ensure safety and reliability. As this debate grows online, the story starts to attract wider attention, eventually pulling in major public figures like Elon Musk, who has previously spoken about software control, automation, and user ownership in technology systems. The situation becomes more serious when the rebuild project reaches one of its most important stages, a heavily damaged supercar that comes from a modern performance era where electronics matter just as much as engineering. The car in question is a crashed Ferrari 296 GTB, a hybrid supercar produced by Ferrari. This is not an ordinary vehicle. It is a high-performance machine that combines a powerful petrol engine with an advanced electric hybrid system. Because of this combination, the car depends heavily on software systems to control everything from engine behavior to battery management and driving stability. When the car is in a crash, these systems often become locked or disabled as a safety measure, making recovery much more complicated than older cars. The damaged Ferrari arrives in a condition that most people would consider beyond repair. The front structure is heavily destroyed, suspension parts are broken, and the internal wiring is severely damaged. In traditional car repair logic, this would already be a complete write-off. But in the world of high-end rebuilds, especially for someone like Mat Armstrong, a write-off is not always the end. Instead, it becomes a challenge. The decision is made to rebuild the car step by step, replacing damaged components, repairing the structure, and restoring the physical integrity of the vehicle. Over time, the car begins to look complete again, as if it has returned to life. However, this is where the first major problem appears. Even after all mechanical work is completed, the car refuses to fully activate. The engine does not start properly, and the hybrid system shows persistent errors. The dashboard displays warnings that cannot be cleared through normal methods. At first, it seems like a wiring issue or a sensor failure. But after multiple inspections and repairs, it becomes clear that the problem is not physical anymore. The issue is embedded deeper inside the system, in the form of software restrictions that are designed to protect the vehicle after serious damage. These restrictions are not simple bugs. They are intentional safety systems built into modern supercars. When a crash is detected, the vehicle's internal computers may lock critical functions until the system is reset by authorized tools. This means that even if a car is physically repaired to perfection, it may still refuse to operate without approval from the manufacturer. In this case, the Ferrari requires a specific software reset that only authorized networks can perform. This is where the rebuild project enters a new and unexpected phase. The conflict between mechanical freedom and digital restriction as the rebuild continues. The technical problem becomes clearer and more frustrating. The Ferrari 296 GTB does not behave like a traditional machine anymore. Instead, it behaves like a locked digital system. Even though every mechanical component is restored, the car refuses to function because of a software-level restriction inside the hybrid control system. This system is designed to ensure safety after major damage, but also creates a situation where the owner cannot fully restore the vehicle without manufacturer intervention. For someone like Mat Armstrong, this creates a major obstacle because his entire rebuild process is based on independent repair work done outside official dealership systems. At this stage, communication with Ferrari becomes necessary. Requests are made for a software reset that would allow the car to be reinitialized and brought back to working condition. However, the response process is not simple. The manufacturer's system requires strict verification steps, including inspection through authorized service centers and confirmation that all parts and procedures meet factory standards. This means that even if the car has been rebuilt successfully in a private workshop, it may still need to be partially undone or rechecked by official channels before any software access is granted. This creates a conflict between two different approaches to repair. On one side is the independent rebuild approach, where skilled technicians and creators repair vehicles using available knowledge, parts, and experience. On the other side is a manufacturer control system, where software access is tightly controlled and only granted under specific conditions. The tension between these two systems raises a deeper question about modern car ownership. If a person legally buys a car, repairs it, and restores it, but still cannot make it function without permission, then what does ownership actually mean in the digital age? The situation becomes even more controversial because modern vehicles are no longer purely mechanical objects. They are connected systems, similar in some ways to smartphones or computers. Just like a locked phone that cannot be fully accessed without the correct software credentials, modern cars can also be restricted through internal digital systems. This is where the debate begins to expand beyond a single rebuild project and into a broader discussion about technology rights, repair freedom, and corporate control over physical products. As the story develops, it becomes clear that this is no longer just about fixing a damaged Ferrari. It is about a growing conflict in the automotive industry, where software is becoming as important as hardware. And in the background, attention from figures like Elon Musk adds even more pressure to an already intense situation, as discussions about digital ownership and repair rights start gaining global attention. While the Ferrari rebuild situation is becoming more complicated, another parallel project adds a completely different dimension to the story. This involved a wrecked Bugatti Chiron, one of the most advanced hypercars ever built by Bugatti. The Chiron is not just a fast car. It is a highly engineered machine built around extreme performance, advanced aerodynamics, and a quad-turbocharged engine that produces massive power. Unlike simpler vehicles, everything in this car is designed with precision tolerances, meaning even small repairs require deep technical understanding and specialized equipment. In this parallel rebuild, Mat Armstrong attempts something that many consider nearly impossible: restoring a hypercar that most people assume can only be repaired inside factory-level facilities. However, unlike the Ferrari situation, this rebuild follows a different path. The Bugatti does not rely as heavily on locked hybrid software systems in the same way. While it still has advanced electronics, the core challenge is more mechanical and structural rather than being fully dependent on encrypted software authentication systems. This difference becomes very important later in the story. The Bugatti rebuild progresses slowly but steadily. Parts are sourced, damaged components are replaced, and the engine is carefully rebuilt. Unlike the Ferrari case, where the main obstacle becomes software access, the Bugatti challenge is mostly about engineering precision, sourcing rare components, and ensuring that everything fits together perfectly. This contrast highlights a key difference in modern car design. Some manufacturers focus more on mechanical complexity, while others rely heavily on software control systems that can limit what independent rebuilders can do. When the Bugatti eventually comes back to life and the engine runs again, it becomes a symbolic moment. It shows that even extremely complex machines can be rebuilt if the problem is physical and not digitally locked. This success makes the Ferrari situation feel even more unusual. It raises a question: why is one hypercar rebuild possible, while another is blocked by software restrictions even when the physical repair is complete? This comparison starts to shift public attention toward a bigger issue that goes beyond individual cars. As these discussions grow online, the story reaches a new level when Elon Musk enters the conversation. Known for his strong opinions on technology, software systems, and user control, he posts comments that frame the situation in a much broader context. The core idea he highlights is simple but powerful. If someone legally owns a product, they should not be prevented from using or repairing it through software restrictions. This statement quickly spreads across social media platforms and attracts millions of views. The reaction is immediate. People begin comparing the situation to other industries where software locks already exist. Examples include tractors, smartphones, gaming consoles, and industrial machines. The discussion expands into a global debate about right to repair, a movement that argues consumers should have full access to repair and modify products they own. Supporters of this movement believe that ownership should include both physical and digital control. Opponents argue that manufacturers need restrictions to ensure safety, security, and performance standards that in this case. The Ferrari situation becomes a symbol of this larger conflict. The idea that a car can be physically repaired but still digitally blocked creates strong emotional reactions. Some people see it as unfair control, while others see it as necessary protection in a world where modern vehicles are deeply dependent on software. The debate becomes even more intense when engineers and technical experts join the conversation, explaining how modern electronic control systems are designed and why manufacturers implement such restrictions in the first place. At the same time, the story of Mat Armstrong continues to gain attention because it is not just theoretical. It is based on a real rebuild project that is documented step by step. This makes the discussion more powerful because viewers are not just hearing opinions. They are watching a real example where mechanical success is blocked by software limitations. As a result, the story begins to move beyond entertainment and into the territory of real-world legal and technological debate. As the situation develops further, it becomes clear that this is no longer just a single rebuild project involving a Ferrari or a Bugatti. Instead, it represents a much larger shift in how modern machines are designed and controlled. Cars today are no longer purely mechanical objects. They are digital systems built on layers of software, sensors, and encrypted control units. This means that ownership is no longer just about possessing physical parts, but also about having access to digital permissions that control how those parts behave. For companies like Ferrari and Bugatti, these systems are often justified as necessary for safety, performance, and brand protection. Manufacturers argue that modern hypercars operate at extremely high performance levels, and even small mistakes in repair or tuning could lead to dangerous situations. Therefore, software locks and controlled access systems are used to ensure that only certified procedures are followed. However, critics argue that this approach creates a new form of limitation on ownership. If a product can be physically repaired but still cannot function without permission from the manufacturer, then ownership becomes incomplete. This is the core argument that makes this story so powerful. It is not just about one car that cannot start. It is about the future of all vehicles and possibly all smart machines. As technology continues to evolve, more devices are becoming software-controlled, which means this debate could extend far beyond the automotive world. In the middle of all this, the story of Mat Armstrong becomes a real-world example of this transition. A simple decision to rebuild a damaged car turns into a case study about modern ownership, digital restrictions, and the balance between innovation and control. And as public attention continues to grow, the situation sets the stage for what could become one of the most discussed topics in the future of automotive law and technology. As the rebuild of Ferrari 296 GTB moves closer to completion, the real challenge becomes clearer and more frustrating. The physical repair work is no longer the issue. Every damaged part has been replaced or restored. The chassis is repaired, the suspension is rebuilt, the wiring is corrected, and the hybrid components are reinstalled. On the surface, the car looks ready to return to life. But underneath all of that mechanical success, a hidden problem still blocks everything from moving forward. This problem is not mechanical at all. It is digital. The system inside the car, controlled by Ferrari, has placed the vehicle into a lock state. This is a safety mechanism designed for post-crash situations in modern hybrid supercars. When the car detects serious damage, it can disable critical systems to prevent unsafe operation. In theory, this makes sense because it protects both the driver and the vehicle. But in practice, it creates a situation where even a fully repaired car cannot function unless the internal software is reset through official tools. For Mat Armstrong, this becomes the most difficult part of the entire project. Mechanical skill alone is no longer enough. Even expert-level repair work cannot bypass the system because the restriction exists inside encrypted control software. The car refuses to start, and diagnostic tools only return limited information, pointing back to the manufacturer's system. This creates a situation where physical ownership does not automatically mean functional control. At this stage, the problem becomes symbolic. The car is complete in every physical sense, yet still inactive. This contrast highlights the central tension of the entire story, the separation between hardware and software ownership. It shows how modern vehicles can be fully restored but still remain unusable without digital approval. This is where the rebuild stops being just a technical challenge and becomes part of a much larger debate about how far manufacturer control should extend after sale. As the issue escalates, discussions begin to move beyond garages and into legal and regulatory spaces. The situation raises important questions about how modern law should interpret ownership in the age of software-controlled machines. In traditional terms, buy a product means full control over its use, repair, and modification. However, in modern vehicles built by companies like Ferrari, ownership also includes software systems that are protected under intellectual property laws and licensing agreements. Manufacturers argue that these systems are essential for safety and reliability. They claim that allowing unrestricted access to control software could lead to dangerous modifications, security risks, or performance issues that could harm drivers and damage the brand's reputation. From this perspective, software locks are not about limiting ownership, but about ensuring that the vehicle operates within safe and tested parameters. On the other side of the debate, independent builders and right-to-repair advocates argue that once a vehicle is sold, the owner should have full authority over both its physical and digital systems. They believe that restricting access to essential software functions creates an unfair imbalance between manufacturers and consumers. In the case of a rebuilt car, where all physical repairs are completed correctly, denying software access effectively prevents the owner from using their property. This conflict becomes even more significant because it is not limited to one company or one vehicle. It reflects a broader trend across many industries, where software is becoming a controlling layer over physical devices. From tractors to smartphones to electric vehicles, the same issue is appearing in different forms. The Ferrari case becomes a highly visible example of this global shift, showing how deeply software can influence ownership rights in the modern world. As public discussion continues to grow, the story gains even more momentum when Elon Musk becomes associated with the debate. His public comments about software control and ownership in technology systems add fuel to an already intense conversation. The core idea he highlights is simple. If a person legally owns a machine, they should not be blocked from using it due to software restrictions imposed by the manufacturer. This statement spreads rapidly across social media platforms and attracts millions of reactions. It turns a Ferrari rebuild situation into a symbol of a much larger issue involving digital ownership, repair rights, and corporate control. People begin discussing whether modern technology is gradually shifting power away from consumers and toward manufacturers who control software access. At the same time, the visibility of Mat Armstrong increases significantly because his project provides a real-world example of these abstract debates. Instead of theoretical arguments, viewers can see a physical car that is fully repaired but still locked by software. This makes the issue more relatable and easier to understand for a general audience. It is no longer just a technical discussion. It becomes a story about control, freedom, and the meaning of ownership in the digital age as legal experts, engineers, and policymakers begin to take notice. The situation evolves from a niche automotive rebuild into a potential case study for future regulations. The idea that software can override physical repair work challenges long-standing assumptions about property rights. And as more attention builds, the story reaches a point where its impact goes far beyond a single garage.